Position of hydrogen in the periodic table. Hydrogen has both similarities and differences with the top elements of 1A group and 7th A group. 1A group elements are alkali metals, 7A group elements are halogens. Hydrogen will show some similarities and some differences with these elements. First of all, let us understand the similarities of hydrogen with alkali metals and similarities of hydrogen with halogens. Afterwards, we shall discuss the differences of hydrogen from alkali metals, difference of hydrogen from halogens. Let us start the similarities. Here, when we are discussing alkali metals, we know that the list of alkali metals are lithium, rubidium, cesium and francium. Out of these alkali metals, let us consider sodium as our example. Sodium is the alkali metal which we are considering. Coming to halogens, the list of halogens are fluorine, chlorine, bromine, iodine, astatine. Out of these halogens, let us consider chlorine as our example. Now let us start the process. Electronic configuration of both hydrogen and alkali metals is same, outer electronic configuration. For example, if you take sodium, the electronic configuration is 1s2, 2s2, 2p6, 3s1. What is the outer electronic configuration? 3s1. It is ns1. If you take hydrogen, the electronic configuration is 1s1. So in both the cases, the outer electronic configuration is ns1. So both the alkali metals and hydrogen, both alkali metal and hydrogen have same outer electronic configuration. Now let us discuss the second point. Both form unipositive ions. For example, you know that sodium forms Na+1 ion. Hydrogen also can form H+ ion. Therefore, both are able to form alkali metals and hydrogen are able to form unipositive ions. Next, both combine with oxygen, sulfur, nitrogen and chlorine to form oxides, sulfides, nitrides, halides. Let us discuss with examples. The example of alkali metal which we are considering is sodium. Sodium combines with oxygen and forms sodium oxide, Na2O. Sodium combines with sulfur and forms sodium sulfide, Na2S. Sodium combines with nitrogen and forms sodium nitride, Na3N. Sodium combines with chlorine and forms sodium chloride. So oxide, sulfide, nitride and halides are formed. Similar to alkali metal, hydrogen will also do the same. Hydrogen combines with oxygen and forms H2O. Hydrogen combines with sulfur and forms H2S. Hydrogen combines with nitrogen and forms NH3, ammonia. Hydrogen combines with chlorine and form HCl, hydrogen chloride, HCl. So hydrogen is behaving the same as that of the alkali metal sodium. So these are the similarities of hydrogen with alkali metals. I repeat once again, alkali metal and hydrogen both have same outer electronic configuration. Both are able to form unipositive ions. Both are able to form oxides, sulfides, nitrides and halides. So this is the similarity of hydrogen with alkali metals. Now let us discuss the similarity of hydrogen with halogens. The example which we are considering is chlorine. In the first point, both hydrogen atom and halogen atom are in need of one electron to get inert gas configuration. For example, let us discuss chlorine. What is the electronic configuration of chlorine? 1s2, 2s2, 2p6, 3s2, 3p5. Here this is the outermost orbit, and here there are 7 electrons. To get inert gas configuration, it is in need of 1 electron. At present it is having 7 electrons. It is in need of 1 electron to get inert gas configuration argon. This is about chlorine. Now coming to hydrogen, you know that the configuration of hydrogen is 1s1. To get helium configuration, it is in need of 1 electron. So both halogen and hydrogen needs 1 electron to get inert gas configuration. So both have the same nature. So this is the first point. Second point, both form unipositive ions. You know that chlorine forms Cl minus 1 ion. Similarly, hydrogen also forms H minus 1 ion. Cl minus 1 ion is called chloride ion. H minus 1 ion is called hydride ion. So both halogen and hydrogen form uni-negative ions. Next, both exist as diatomic molecules. You know that chlorine exists as Cl2. Hydrogen will also exist as H2. So both are able to exist as diatomic molecule. Next point, hydrogen and halogens have high ionization potential. I am writing the configuration of chlorine: 1s2, 2s2, 2p6, 3s2, 3p5. Here this is in need of electron. Take electron, but it will not give away electron. Therefore, if we try to remove the electron from this atom, we need to supply very high energy. Therefore, chlorine is having high ionization potential. Just as chlorine is having high ionization potential, hydrogen will also have high ionization potential. Why? Because hydrogen is having only 1 electron. If you try to remove that electron, it will be difficult. So hydrogen is also having high ionization potential. Right. So these are the similarities with halogens. I repeat once again, both hydrogen and halogen are in need of 1 electron to get inert gas configuration. Both hydrogen and halogens form uni-negative ions. Both hydrogen and halogens exist as diatomic molecules, and both of them have high ionization potentials. So we discussed the similarities, and now we are going to start the differences. Hydrogen is a little bit different from alkali metals. Again, hydrogen is a little bit different from halogens. Let us see the points. Number 1, for the alkali metals we are considering sodium. Okay, alkali metals have low ionization energy. For example, sodium is having low ionization energy. Why? Because the configuration of sodium is 1s2, 2s2, 2p6, 3s1. Therefore, when we remove this electron, it will get inert gas configuration. Therefore, it will easily give away the electron. Therefore, alkali metals have low ionization potential because it will easily give away the electron. So alkali metals have low ionization potential, whereas hydrogen have high ionization potential, high ionization energy. Just now we discussed here, hydrogen has high ionization potential. So here hydrogen is having high ionization energy. So alkali metals have low ionization potential, hydrogen have high ionization potential. Right, next point. Hydrogen is much less electropositive than alkali metals. We are talking about electropositivity. When we talk in the terms of electropositivity, alkali metals is greater than electropositivity of hydrogen. So a lot of electropositivity difference is present between hydrogen and alkali metals. Next point. Alkali metals are monoatomic. Hydrogen exists as diatomic gas. We know that alkali metals are solids. You know that in metals the atoms will be present with metallic bonds. So we consider metals as monoatomic. the constituent particles are atoms. But in hydrogen, the constituent particles are molecules. What are they? H2 molecules. So hydrogen exists as diatomic gas. Next, H2O is amphoteric oxide, whereas alkali metals are basic. What is the meaning of amphoteric? It can react with both acid and base. So you know that H2O is amphoteric. There is no doubt about it. Whereas oxides of alkali metals, for example, sodium oxide Na2O, oxides of alkali metals Na2O is basic. It is basic in nature. Oxides of alkali metals are basic. So here it is amphoteric, here it is basic. Right. Now let us come to the differences of hydrogen from halogens. Halogen is more reactive, hydrogen is less reactive. There is a difference in reactivity. Halogen is more reactive, hydrogen is less reactive. Next point, halogens are highly electronegative and hydrogen is less electronegative. When we are discussing the electronegativity of chlorine and hydrogen, chlorine is very much electronegative than hydrogen. Halogens are highly electronegative. Hydrogen is not that much of electronegativity. Right. Next, H2O is amphoteric. The oxide of hydrogen H2O is amphoteric. It can react with both acids and bases. But oxides of halogens are acidic. For example, when we take chlorine, one oxide of chlorine is Cl2O7. It is acidic oxide. So oxides of halogens are acidic, whereas oxides of hydrogen is amphoteric. Oxide of hydrogen is amphoteric. So here we are able to understand that hydrogen is a little bit different from alkali metals, and hydrogen is a little bit different from halogens. In the first part we discussed the similarities. In the second part we discussed the differences. So what we are able to understand is hydrogen is having some similarities and some differences with halogens and alkali metals. Therefore, the position of hydrogen in the periodic table has become a question mark. They have placed hydrogen separately in the periodic table. Hydrogen is placed neither in 1A group or 7A group. It is not placed among halogens or it is not placed among alkali metals. It is placed separately in the periodic table. For example, if we draw the periodic table in a rough diagram, this is S block, this is D block, this is P block, and this is F block. Hydrogen is not placed here, nor hydrogen is not placed here. It is placed separately in the periodic table. The position of hydrogen is separate in the periodic table. Even though it is present on the top of the alkali metals, it is not counted as alkali metal. It is written separately. So the conclusion is, the position of hydrogen in the periodic table is separate in the periodic table.